Okay, we're going to go ahead and graph our last relation using interval notation. And here it is. This says the relationship R equals the set of any point on the plane such that y has to be between -1 and +3. And not inclusive because it's not a less than sign. But let's go ahead and pull up our graph. What you should notice is that there's no x restrictions. So that means that any x on this line can be used. All of them can be used, okay? So there's no restrictions on the x, but there are restrictions on the y such that y has to be between -1 and 3. So let's just pick a value for x. I would start with 0. 0 is easy to work with. So when x is 0, the notation says that we can use the y's anywhere between 3 and -1. Okay, there should be a little circle on the top of this thing, but because there are more than one possible x's, we're going to do that at the end. So if we pretend x is 0, this is what the graph would look like. But x can be any number. So if x was -1, this was what the graph would look like. If x was +1, this would be the graph, right? And it's all of these combinations of x. If we went out to 6, it would look just like this, right? If we went out to 106, it would look just like that. -6, same thing. If we went to 2.5 or 2 2/3, which is still a possibility for x, it would look like that. So in other words, can you see the pattern that's starting to form out here? No matter what the x value is, the y value restrictions are going to be between 3 and -1. So if you did them infinitely small, you're going to get like a graph, like a box, like a rectangle. The left and right sides are going to go on for forever, right? But the up and down are restricted to the 3 and the -1. And because it's a less than problem, you're going to put little dotted lines up there. What that means is that you will not include the number -1 in this relation, or you will not use 3, right? You will not use y equals 3 or y equals -1. But that's it. MGZ out.